Hello everyone, I'm Gary Roberson, Professor and Extension Specialist, Biological and Agricultural Engineering, North Carolina State University. Welcome to Cherry Research Farm, Goldsboro, North Carolina. Precision agriculture is a management strategy that incorporates information that we glean from reams and reams of data, as well as technologies that we can use to put that information to work. With respect to the technologies, this is a pretty long list. Some of the technologies that we use are farm management information systems, which is basically the computer system that farmers use to manage their information. GPS, or GNSS as it's called now, is one of the backbones of the whole system. That's our positioning information, global positioning system. Automatic steering, guidance, yield monitors, crop sensors, soil sensors. UAVs now are coming into play. We have a lot of data we're gathering off of unmanned aerial vehicles. We've got another project going on that here on the station. Growers are using UAVs for everything from stand counts right up to looking for disease pressure, looking for crop damage due to drought, excessive rain on the other end of the spectrum, disease. We've even tracked crop damage due to microbursts from wind. And bears in the field. We can do lots of different things with aerial imagery. In addition to the UAV gathered data, the imagery, we can also get imagery from satellites, and we can also get imagery from agricultural aviators. A number of them around the country, and perhaps some around the state, are also offering an image gathering service as well. What most farmers are using for satellite services is coming from three different sets of satellites. One is Landsat, which is NASA, and there's a lot of providers that are then taking that information and streaming it out to farmers. Sentinel, which is the European Space Agency, and Planet, used to be called Planet Labs, now Planet Corporation. In addition to the other technologies, we also have, of course, the capstone technology, which is variable rate. Variable rate, of course, is where we apply different crop inputs, everything from seed to fertilizer, herbicides, pesticides, insecticides, fungicides, even water, on a site-specific management scheme. Whatever that part of the field needs, that's what we try to ensure that it gets, no more, no less. One of the projects we've done here in the past, and this was done here on this station, was variable rate herbicide application on soybeans. And this was done several years ago, so we've been engaged in this for some time. What we're doing is looking at combinations of herbicide. For example, you may be looking at a grass herbicide versus a broadleaf herbicide. Weeds and such we know are patchy within fields. If you've got a patch this year, you're likely to have it there next year. There's no point in putting a broadleaf herbicide on a grassy weed or vice versa. So by separating the two herbicides and injecting them into the water flow, we can selectively apply the product we need at each part of the field. In fact, we're doing that even now with cotton, not just with herbicides, we're also doing it with plant growth regulator and defoliants. In fact, that's an active project we have this year. The most common starting points for precision agriculture for North Carolina growers, and this is in no particular order, we see a lot of growers interested in starting first with automatic steering. And they may start with automatic steering at an entry level, which is just a standard correction, or they may go all the way to RTK. We're lucky here in North Carolina because we have a statewide network that gives RTK corrections, and they don't charge for it once you buy a port into the system. At present, there's no charge. That may change in the future. They may have to implement a user fee just to keep up with maintenance, but it'll be a minimal fee at that. Right now, you buy a port into the system. That's a one-time fee, $500, gives you 2 ports. The only monthly expense you've got is your cell phone plan. They do not charge for the data. North Carolina is very lucky in that regard. But automatic steering is a common point of entry. Yield monitoring is a common point of entry. People think, well, the yield monitor, that's the last step, isn't it? Well, no, not really. Getting data off a yield monitor can be the first step, because you see where the problem areas are. So yield monitoring is one. Just adopting a farm management information system, keeping records, computerized records in the farm office, is an important step. UAVs now have given us another common starting point, getting imagery of the crop as it's growing. You're looking for patterns, you're looking for anomalies, you're looking for washouts, you're looking for all kinds of potential problems in the field, and you can see them a whole lot better from the air than you can from the ground. Satellite imagery available as well, not quite as detailed as our UAV imagery, but it's certainly out there. Those are the common starting points. Some farmers like to start with adopting precision sampling or precision scouting, which basically draw a map of the field, break the field down into zones, send somebody to that specific zone to take a soil sample or look at the crop as it's developing, do a weed count, look for disease pressure, look for insect pressure. But we're doing that all over the field, not just going around the edges. So, those are the common starting points that I see around North Carolina. There are some ROI calculators online that farmers can employ, and they are ballpark in some cases, and they're coming from lots of different places. John Deere has one, for example. Trimble, I believe, has one on their website. Kansas State's done a lot with that as well. They've got one on their website, and believe it or not, they actually have some routines set up that fit our fields pretty well. Oh, really? Small and irregular. But yeah, there are a lot of return on investment calculators available online. The trick is to get one that relies on the kind of information that you have available and is appropriate for the kind of farming operation you have. What fits the Midwest doesn't necessarily fit here. That's what we got to be careful about. I talked to a grower several years ago who had just bought a full automatic steer system on his tractor, and at that time he was looking at an investment of about $40,000, and he said that it would pay for itself in about 2 years. And I said, well, that's kind of surprising. What are you doing to make it pay for itself that quickly? And come to find out, he was planting vegetables, but he had to plant on top of subsurface irrigation. RTK, or automatic steering, accurate to an inch or two in the cab of that tractor, was absolutely essential to making sure that he was always planting on top of that subsurface irrigation. That's where he was getting his payback. We did a project with peanut growers where we got payback on automatic steering in about 1.5 years for the average size operation, all because just by keeping the digger on the row where we planted, we increased yield over 300 pounds an acre. That's not additional peanuts being grown. That's more peanuts that were grown being pulled out of the ground because we could go get them more effectively, more efficiently. The big difference in challenge-wise for precision ag here versus the Midwest, field size has something to do with it, but on the other hand, diversity of crops has a lot to do with it. High-value crops that we have in North Carolina, and then you can get off into tobacco and vegetable crops and all kinds of things, they have a whole different set of circumstances. A lot of different technologies, and they're coming from a lot of different companies. That's the first problem. Everything's got to talk to each other. The companies are doing a pretty good job now of making things interchangeable. For example, in the cab, a lot of the field computers we use have an isobus terminal built in them. So as long as the implement and the tractor are both isobus compatible, even though one may be red, the other one may be green or blue, they can still talk to each other. We're not 100% compatible just yet, but the companies are moving more and more that way. Tractor behind me is an example of some of the technology we use now. It is fully equipped with a number of options, and we'll get back to that in just a bit. It is fully equipped with much of the precision ag technology that are appropriate for a planter. It can do variable rate in terms of seed population. It can do multiple varieties if we wish. It has the delta force system, as you can see here. Hydraulic cylinders supplying pressure to the closing or the firming area. And it has the smart firmers in them as well, which is in itself a sensor system, which enables it to collect data while planting. All of that is being fed back through the wiring harness up into the field computer in the cab of the tractor. In the cab of this tractor, you see a lot of our precision ag technology set up. We've got a couple of field computers plus the tractor's built-in console for control. We're running a one field computer up here, the Trimble TMX. At this particular setup, it's only controlling steering. So this is a full auto steer equipped tractor. It is using RTK correction. So we can, of course, control steering accuracy down around an inch or two. We also have the precision planning console up here, which is actually controlling the planner. And all of its functions are feeding through that. Data is being shared somewhat between the different screens. And then, of course, we have the built-in console for the tractor down here, which controls all of our working functions and other aspects of the machine in operation. All of this information then boils down into a comprehensive management strategy. So we put all these technologies together. It's like fitting together a giant puzzle. Lots of different pieces, lots of different technologies that do specific things. And again, once we put them all together, combine our management scheme, then we have what we call precision agriculture.